Now that we have some results to work with, let's talk about the results pane. The first thing we can do is enlarge the results pane so we can see our beautiful results a little better. All right, so these results aren't particularly beautiful, but they're not terrible either. First, we have our chromatogram title. We can give our chromatogram a title simply by clicking on the title and typing. We then hit OK and save our chromatogram. Now that we've saved our chromatogram, we can refer back to it at any time. Just under our title, we have our modeled chromatogram. We can zoom into the chromatogram, and when we hover over our peaks, we can see compound names for our peaks. One really nice thing about this interface is that you can see information for your co-eluting peaks simply by hovering over them. Using this feature, we can see very quickly that we have a problem with a coelution between hexane and chloroform. Let's zoom out by double-clicking and take a look at our conditions. Under our chromatogram, we have the set of conditions that the modeler used to generate this chromatogram. We have information for our column, carrier gas, flow rate, and oven program. Note that no inlet parameters are supplied because those are outside the scope of the modeler. Below our results, we have our peak list. The peak list shows retention times, resolution values, peak widths, and elution temperatures. Note that the resolution values are calculated relative to the closest eluting peak, rather than the preceding peak, like most chromatographic software packages. We can see this for hexane and chloroform. Both compounds show a resolution of 0.4. In other chromatographic software packages, hexane would show a resolution value of around 2.5, while chloroform would have a resolution value of about 0.4. Resolution values falling below our minimum resolution will be highlighted in red or orange, depending on the severity of the coelution. Also note that the peak widths are calculated based on ideal injection conditions. So if you're using injection techniques that require some optimization, like splitless or headspace, then the peak widths you get from your instrument may not match those displayed here, especially at the beginning of your run. We'll talk more about that in video 3. The last column denotes the elution temperature of each compound. This information is useful if you're going to manually optimize your oven program. With this information, you can optimize only the portion of the oven program ramp that you need to. The last and most useful portion of the compound list is the compound information that is included with our compounds of interest. If you click on the small magnifying glass next to any compound, you will be able to see all of the database information we have available for that analyte. So if we just take a look, this information includes our molecular structure and the physical properties of our compound of interest. The other really useful piece of information you can get here is the mass spectrum of our compound. We can zoom into the spectrum easily just by clicking and dragging and see just relative ion abundances. And if we want exact ion abundances, all we have to do is hover over the top of each mass, and we can see our abundance here and our abundance here. So if we have to calculate relative abundances accurately, then we can do that as well. This feature is absolutely wonderful for MS users. Let's close this up. As if instant access to compound and spectral information isn't great enough, we've gone a step further. If we have compounds that don't meet our resolution criteria and we're MS users, we'll want to compare those spectra to determine whether or not separation of the two compounds is necessary. Let's take a look at chloroform in our example. If we scroll down to the mass spectrum, we can see a small, unassuming button labeled Show Coelutions. When we click that button, any compounds near hexane not meeting our resolution criteria will be overlaid on top of our original spectrum. This makes spectral comparisons a snap and is a great tool for MS method development. The spectral comparisons will compare up to 3 spectra, so if you have 3 co-eluting compounds, you can click on the middle one and it will overlay the other 2 on top of it. So we can see in this case that we don't really have anything to worry about so far as this coelution goes, as long as we're MS users. That's about it for the model pane.